Hello, we're going to start in on Understanding Nursing Research. This is Chapter 9 in Grove and Gray. So that's this book here. And we're going to go through some of the things that you'll need to know to be able to decipher research clearly. So this starts with examining population and samples. So sample size and sample method are both really important to making valid sampling choices. So if you don't have the right sample size or you don't have the right sample method, you end up with a study that really doesn't represent what you're trying to say. So sampling by itself is just selecting that group of people, events, objects, other elements, whatever it is you're trying to study, with what you want to do. So it's the sampling method is how that's done, and then the sample defines the group that it's done to. So samples should represent a population. So here we have kind of an example of a population. So our sample should have good representation of all of the people in that population. So population is a particular group of individuals or elements. It can be a population in a lot of different ways. So the United States population as a whole is a population. But within that population, you have the people of Illinois. And within the people of Illinois, you have the people of Shiloh. And within the people of Shiloh, you have the people who attend Shiloh United Methodist Church. So a population is just the particular group of individuals or elements that you're studying. Target population is the entire set that meets that sampling criteria. So if we're studying the entire population of the United States of Illinois, that includes every single citizen or population in that country or that state. Accessible population is what you have access to study. So if you want to study the entire population of the U.S., it's really difficult to do. We don't even get a 100% compliance rate on our census taking. So we have an accessible population, which is determined by sampling criteria. And that could be maybe a percentage of, based on population, a percentage of the number of people per state. So if, and this is a total estimate, if 300 million people live in California and 20 million people live in Wyoming, then you would want to take a percentage of those that makes your sample have more Californians than people who live in Wyoming. Sample is what you get when the accessible population uses whatever method you choose. So sample is out of that. So you're not going to be able to get your whole population. So we work out of a sample of the accessible population. And then element is the person, object, or participant of the study. So the element is the thing that we're trying to study. The sample is what we're getting that information out of. We draw that from the accessible population, which was made up of our target population, which was determined by sampling criteria. We'll cover that later. And that all comes out of the whole population. So they're all relative to another, but it's really important to pull from the right sources to get what you need for your study. So populations, in generalization, extends the findings of the study to the rest of the population. That's our goal here as researchers. We want to say if this small portion of people had this happen to them, the rest of the population of people that we can't access to sample would also have that happen to them. So the quality of the studies often determines whether or not it's generalizable, and that's usually directly related to sample size. You should find those generalization reports in those study findings. It's something that they're supposed to list. So here's another good example here. This one is too small of a sample, so we don't have enough data here to truly make a determinate result. This one is not representative. We only have one pink here, and we've got a whole bunch of green. There's a whole bunch of pinks in the sample, so we didn't do a good job of getting the right population. Sample 3 is a good example of what this should look like. So eligibility criteria is the list of characteristics essential for eligibility or membership in the target population. So if we're studying people with heart failure, people who don't have heart failure aren't going to be part of our sample. So that's inclusion sampling, and that means the characteristics needed to be part of the study are included in the population you're studying. So for example, if you want to study people with cancer, then the person needs to have some form of cancer in order to be eligible to participate in the study. Exclusion characteristics means the person would have met inclusion criteria, but they had to be removed for some reason. So maybe they do have cancer, but what you're looking for is lymphatic cancer, where they have bone cancer. So some samples are also homogeneous or similar, which means they control for outside variables. In a study about a very particular thing, this gives us better results because everybody's pretty much exactly the same. We also have heterogeneous or dissimilar samples, which creates more of a generalized look. This is more of a generalized look of a population as a whole. And then representativeness means that the sample or the accessible population and the target population are actually alike. So the people in our sample actually do meet the qualifications of our population. And then large samples generally are more generalizable because we have more people, so it kind of evens out our trend. So variations can include random variations, and that's the expected difference in values that occurs when different participants from the same sample are examined. They might be higher or lower than the average value. So if we look at test scores, for example, some people are always going to do really well on a test. There's always going to be a couple of people that don't do very well on the test, and the most of us are kind of in the middle there at average. As the sample size increases, those numbers eventually average out, meaning the sample is closer to a bell curve or that normal distribution, which is what we're looking for. Systematic variation is a bad thing. So that measures varies from the actual population, and most of the variation occurs in the same direction. So you can kind of see that on the bullseye here. Here's an example of unsystematic variation, and here's systematic variation. So is it accurate or is it inaccurate? So here, we had precise data, but we missed the mark of what we were looking for. And here, we had both accurate data and it was precise, so we hit the bullseye. And if it's imprecise, that means we're kind of all over the place. We're not really catching what we need. And then inaccurate means we're missing the mark 100% of the time. There's no variability there. That's a good thing. So then we have acceptance and refusal rates. So when samples aren't randomly taken, the chance of systematic variation increases. So when we start to introduce bias into our samples because we're picking and choosing who's a part of our sample, then we start to see some of that systematic variation where we're maybe not hitting the bullseye like we're supposed to be. If more people decline to be part of a study, that sample automatically becomes more biased. And then refusal rates is the percentage of people who were asked but declined to participate. Acceptance rate is the percentage of people who consented to be in the study. So we report one or the other, not both. So for example, here we have vaccine refusals. So we didn't go on the percentage of people who didn't refuse. We're reporting the number of people who did refuse. You don't need one or the other because everything should add up to 100%. So if 3% of people refused vaccines, that means 97% of people did get the vaccine. And quite often you'll find that the way that this is reported depends on the bias of the reporter. So we could talk about how vaccine refusal rates are actually going down, which by the way they are. But you know, if your paper or your article that you're trying to provide is to prove that people still aren't vaccinating, that's not how you're going to represent the data. You're going to say that there's a 3% refusal rate. You're not going to say there's a 97% acceptance rate. So that also leads us to sample attrition and retention. So systematic variation also occurs when too many people withdraw or become ineligible in a study. We see this in our really long studies. For example, the most recent vaccine study that came out took place over the course of, I think, 15 or 20 years. And in that 15 or 20 year mark, you can imagine the number of people who said yes and were gung-ho and went to every appointment in the beginning starts to drift off. And that's when we get attrition. It's withdrawal or loss of participant from a study, and it's usually expressed as a percentage. So if you started out with, let's say, 100 people, and then you slowly over time lost 30% of them, you now have a much smaller sample, and that can actually cause some problems for you later on down the road. Sample retention is the opposite. That's the number of people who remain in a study until it's absolutely completed. Higher retention rates typically mean better samples. So let's talk about the types of sampling. So random sampling means everybody in the population has the same chance to be a part of the sample. This would be great if we could do this consistently between groups, but it's not always possible. So our goal then is to get a sampling frame. We want a list of everyone and then to make sure that they all meet those inclusion criteria. We try to narrow our sample down so that we're actually measuring the object we're trying to measure and not generalized characteristics of the population. So complete samples are pretty rare, and that's for a couple of different reasons. One, it's very expensive. Think of how much time and effort and energy it takes to do one population census every 10 years. They need a lot of volunteers. They end up paying people to be census takers. People have to try to reach every single person in the phone book. There's not even really a phone book anymore. They look at tax documents, information like that. So it's very expensive and very time consuming to create a true, complete random sample. The other concern we have as healthcare providers is actually HIPAA. So we quite often don't have access to an entire sample because we only have access to the ones that we should be looking at from a HIPAA perspective. So your sampling method or plan is basically just your strategy used to obtain the sample. It's going to vary by study, and it may include random or non-random samples, and it just depends on the type of study as to whether that's an acceptable choice or not. Assess this in any study you read. Poor samples lead to poor research. So if you can't trust the sample, or you can tell right from the beginning that their sample size was too small to make a difference, then it's not really valid research. And we see that a lot in things like Facebook or less than accurate news sources like magazines and things like that. So we have probability sampling, and that means, we already talked about that. Without random sampling, researchers may conscientiously or unconsciously select people that match their hypothesis. So the goal of random sampling here is to prevent bias. There's 4 types. There's actually a table on page 238 that's a really nice tool to determine whether your sample is quantitative or qualitative, but simple random sampling is your most basic, and it's achieved by literally randomly selecting things. You could write people's names on a piece of paper and draw them out of a hat, and there's a lot of electronic methods that you can use. There's a table of random numbers, which really just means that you assign names to a number and you pick them out via this table. So there's a ton of different ways to do it, but the goal here is that there's no bias involved. We also use stratified random sampling, and that's used when the researcher knows what variables in the population are critical to provide a representation of the population. So a lot of that includes age, maybe gender, race, socioeconomic status, a diagnosis for us in the healthcare field. Geography sometimes is a big deal. So we use simple random sampling first, and then we sample again using a stratified sample. So for example, if the researcher can target the number of random people who meet the strata, which means we know we have in our population 60% of us are white, 20% of us are black, 15% are Hispanic, 5% are something else. So we will randomly choose people that meet those needs. So we're still random, we're still not biased in our choices, but we're meeting the same percentages that we know already exist in our population. Cluster sampling is the researcher making a list of all the states, the cities, hospitals, doctors, or whatever that can be linked to the identified population. So randomized samples is then used in the study. So it's common when geography matters, but it's too expensive for us to do a complete study. It's a complete list not available to make a sampling frame, for example. So if we're talking about maybe marriages where one spouse cheated on the other. That's not reported, it's not a factual number somewhere, and it's not something that we have the ability to create a full population of. So we'll take a certain percentage of people from each state, we'll randomly select cities and towns and countries within those states, and then we randomly select maybe marriage inside those cities and towns, and then we can figure out from there a relatively representative sample. We also have systematic sampling, and that's used when an ordered list of all members of the population is available. So researchers select the kth available individual. So all that means is that if you had a giant group of people, you would pick every 5th or every 6th or every 7th person in the group. So it's still random because you have every single person available. This one's pretty rare in the field of healthcare, except for when there are very, very small groups, like very rare conditions or disease processes, that we have a complete sample. So non-probability means that not every person has the same chance to be chosen for that study. It's commonly used in nursing because we have a limited number of people we can study. The most common is convenience sampling, or it's also called accidental sampling, and that's where participants just happen to be in the right place at the right time. It can unfortunately cause a lot of biases, but it's very inexpensive, it's easily accessible, takes a lot less time, and it is actually pretty good for limited samples or small populations. So, for example, if we were to do a study between Tele A and Tele B, a convenience sample would be the people in Tele B get one intervention, and the people in Tele A get the standard intervention. So there's no choice that goes into whether or not you end up on Tele A versus Tele B, so it's a convenience sample. We also can do quota sampling, which is basically a convenience technique with a strategy to include participants that are likely to be underrepresented. So researchers have to identify subgroups. So for example, if we know of the patients that we see, the majority of them are between ages 50 and 60, and then 70 and 80, and we know we get a very small percentage of people who are ages 18 to 22, we can kind of guarantee that we're probably not going to get a whole lot of 18 and 22-year-olds in our study, if any, simply because we don't see a lot of them. So we can add one or two, maybe not so much at random, so that we know we're getting the right population of our patients. So sample size is inadequate to make or break your study. So sample size can make or break what you do as a researcher. Problems can be assumed when no significance is found for the hypothesis in the study. You guys are going to learn more about the hypothesis and rejecting the null in your statistics lessons. And then there's a power analysis, which is the ability of the study to detect differences or relationships that actually exist in that population. So the minimum acceptable is usually 0.8 or 80%. The higher the number, the better. I will tell you for most medical research, the minimum is 0.05%. The effect size is the extent to which the null or statistical hypothesis is false. So that's the strength of the relationship between two groups, if the effect size is smaller with smaller samples. We also have some quantitative studies, so that's descriptive and correlation studies that often require very large samples. Many researchers use subgroups within those to compare data to similar things. So they may have all of the data available, but then they'll divide it into subgroups to see if there's differences between them. So for example, if I asked men and women what their favorite activity is on downtime, I would want to know the difference between men and women. Maybe I'd want to know the difference between children versus teenagers versus young adults versus middle-aged adults. So we could go through and kind of decide if there's a correlation between one group versus another group when they were all asked the same question. There's more control in a study where the smaller sample size, as long as it's still reliable. As the number of variables in a studies increase, the sample size needs to be larger because otherwise you're going to have a lot of outliers. If you recall, we want that on the bell curve, so there shouldn't be a whole lot of outliers out here and there shouldn't be a whole lot of outliers out here. So we need it kind of in the middle. So a larger sample helps you even that out. And then the right tools need to be used for specificity and sensitivity, as well as tools used to analyze data. So qualitative research is conducted to gain insight and discover meaning about a particular phenomenon. So the intent there is an in-depth understanding. So the data is usually subjective, but we do purposeful sampling. We'll either be judgmental or selective in our sampling, and the goal here is to purposefully include certain people or events. So if we did a random sample of the population and asked them about a car accident, we would get a limited number of responses that we needed. So in this one, we're saying we don't really care if it's random because they have to have met this inclusion criteria, and we can pick a higher number of people if we already know that that inclusion criteria exists. So we have network sampling, which is snowball or chain sampling. This is really important for subjects that researchers would otherwise find very difficult to reach. So for example, rape victims, drug users, adultery, grieving spouses. Again, there's not scientific evidence that these populations exist. We know they do, but they can be very difficult to find. So typically, a drug user doesn't just come up to the researcher and say, yes, why in fact I do take cocaine on a regular basis. I would like to be a part of your study. The best way for them to maybe find these subjects is to find their friends. Or once you get one drug user, it leads you to another drug user. So that's called the snowball method. Theoretical sampling is used to develop a selected theory or model. And data is considered relevant if it includes enough information in these. And theoretical sampling helps by providing generic information needed by a lot of people to make connections in data. So for example, theoretical sampling would be used when you're just starting out. You think maybe there's a correlation between children who grew up in low-income houses and, let's say, higher instances of pneumonia down the line. You don't really know that there is enough data to support your hypothesis. You don't even know that you can really form a hypothesis at this point. But what you need is a whole lot of generalized information about those subgroups of people to figure it out. So sample size must be large enough to determine variables or differences between groups. I'm going to be different than you are. If 33 of me are different than 33 of you, then we can assume that that difference is statistically significant. The goal is determining relationships. Saturation occurs when newly collected data begins to be the same as what was previously collected. So for example, in my Skills Day survey, I got about 800 responses. At about 600 responses, most of the responses were exactly the same. So I could have ended the study at 600 rather than keep going until I hit the 800 mark. And then scope. So broad scopes cast a wide net, and narrow scopes tend to have less people. So if I want to know the generalized emotions regarding the COVID-19 virus of the United States, I need a wide net for a lot of people. But eventually I'm going to hit saturation, right? There's a couple of different types of people who are having this problem. Either they are highly anxious and highly concerned, maybe they are nonchalant about it and don't think it's a big deal, or they're somewhere in the middle. So eventually I'm going to saturate based on the population. Whereas if I want to know how people who have high blood pressure and a broken left toe are dealing with the COVID virus, then I have a much smaller net of people, but my results are going to speak louder because it's a very specific finding. So it kind of depends on the nature of the topic as to whether that's going to work for you or not. Fewer participants are needed for easy topics. The more complex you get, the more people you need to make a study statistically significant. And then the quality of information. So high quality information means there's got to be a smaller sample, or there can be a smaller sample because it's harder to get really good high quality data. And for example, in qualitative studies, a lot of times that's asking questions. So I'm going to get a lot more data by sitting down and interviewing a person one-on-one with 100 questions than I will asking 300 people 10 questions. So that's kind of the difference there in the quality of information. And then study design. So more interviews per person means better data, and families provide more data than individuals. Then we also have research settings. So that's kind of in the room where it happened. So is it a natural setting? Oh, I have a dog trying to get my attention here. In a natural setting, it's uncontrolled or real life situation. So for example, if I went to the mall and I just observed people, maybe I was trying to determine a difference between people who are likely to be mall walkers and people who are not. So if I went through and studied those people, that would be a natural situation. We can also have partially controlled, which is an environment that is manipulated or modified in some way by the researcher. So say, for example, I open up the mall an hour early, so I know that I'm more likely to find more mall walking people versus non-walking people because the shops aren't open yet. And then there's highly controlled, and that's an environment absolutely structured for the purpose of conducting research. So we control for all of the variables that could possibly happen, so we make sure that we have the most high quality data in relation to what we're actually trying to study. So that's it for this chapter. We'll move on and get to the next chapter after this. If you have any questions, let me know.